hear me? I think so. Perfect. Can we start? Okay. So, yay! Hello. My name is Sylwia, and I am a proud member of Luna developers team. So, what is Luna, and what I will be talking about today? Luna is a purely functional, statically typed language we developed during last, I think, two years. And the special thing about it is that it has the standard textual version, but also it has the visual part. I will talk about this today. So the overview, the agenda is why we want to develop the next language. We have plenty of them. Why we bother? Is Luna a solution for anything? And then the short language technical overview, and I want to present our current state of the project. So, this is strongly my perspective. I was not born as a software developer or something like this. I was a material scientist. I was doing my PhD in physics, working on multi-scale material simulations. So, working at the academia is different than at the industry, because, well, the point of it is that you can use any tools you want to just to achieve your goal, like to get the model for the material or something like this. So the people I was working with were using plenty of different languages, like Python, Perl, Fortran, C++. And the next person who was joining the team was rewriting the things we had already in our code stack to their own language. So I thought, this is not really working properly. It is not really great. So maybe we should get the idea of something common to just process the data together better in a better way. And I have learned about the functional programming, and it was like, whoa, that should be great. So everything will be a function. It will be easy to apply. So it will be statically typed, perfect. And, well, if it compiles, it won't have just runtime errors. So great. Well, then I have started to learning Haskell. And, well, I got it that I will not really be able to pass this idea to my colleagues. So if someone was writing Fortran scripts for the last 20 years, he will not be able or want to learn Haskell, because the amount of work he has to put there is way, way too big. So was it just my problem, or this is the general problem we have? Each year, we are producing huge amounts of data, really, really big. And it is constantly growing during the years. It is exponential. So in 2014-15 years, we have produced more data than in all previous years. But we are not able to process all of them. We just, in 2015, processed about 0.5% of the data we did produce. So because we have so many things we can get from this, we can solve really, really complicated problems. But complicated problems needs complex solutions. So it is making our software more and more and more complicated. Is there any idea what to do to make it better? Maybe we should work on better tools. So there is a certain cognitive aspect, like the cost you have to pay to learn new tools. If you would ask me if Haskell would be good for the problem at the academia, no, of course not. Maybe everyone should start using Python. Python is great for this, isn't it? But even those scientists who were writing the Perl scripts, they didn't want to learn the new language. So it is the same for the developers. If they have to learn the new language, it takes time. So maybe we should just use the developers to produce the tools. It will be great. They know it better. We don't have to force all the scientists and, I don't know, data scientists to write really super complex programs. But if we want the developers to solve the certain complicated problem, we have to teach them about this problem. So we have the communication barriers there. We have to, if I want to, let's say, you are a physicist, experimental physicist, and you are going to CERN to do huge measurement. You are producing tons of data, and you are not able to process them with the tools you are usually using for it, like Igor or something like this. Okay, so CERN has his own Python developers who are producing the scripts to preprocess this data. So happy you are going home with the data and the scripts. And during the evaluation of the data, you are getting the problem, okay, something is wrong. I have to fix the script to preprocessing. But how would you do this? You had some programming course 10 years ago, and it was C or something like this. So you have to find another Python developer here and give him all the knowledge about the program and the problem you are solving, or you can just resend the code to the original developer, wait for the response, and just send the emails all over again. It is not the best idea, isn't it? So this is showing also the second problem. If you even get the new Python developer who will happily join you with this code you brought with yourself, it will be pretty hard for him to solve your problem because he doesn't know what it is all about. He doesn't know a code. He has no idea about the abstraction you use in there. No idea. So what can we do to do it better? We can, well, draw a diagram. Why not? How many of you does it? If you are writing the code, for the documentation or something like this? Yeah. Oh, great. 3 of you. Awesome. So, is Luna a solution? I think so. I believe so. So, we have the dual representation. We have the code. If you don't like the graphical view and clicking and stuff, you can just write a code. On the other hand, you have really clear levels of abstraction and the nodes with the graph. And you can see how the data is changing during the time or applying the functions. How does it really work if you want to work with the graph? This is the film, not the live demo. So let's assume you want to connect to the endpoint. It is the endpoint for the Krakow trams, and you want to visualize where they are. You can do this. So you get the data, you can search them. Okay, there is a huge amount of data. A huge JSON is coming. So you want to filter them to get just the proper informations. Why not? But the common problem people are saying that there is, you will have more and more and more nodes every time, so it will be messy. No, it doesn't have to. You can just put them all together, creating the new function, using it later. So if you will be writing the program to analyze those huge amount of data, first of all, you will check the first line, and try to visualize just the one tram, where it is. So you are taking important information from this, like location. Exactly. Now you will need a name of it. Why not? and the ID of the tram. Perfect. So then you can insert it into the new object to put it into JSON, which you will be able to visualize to put on the map. Perfect. So now you can see it on a map. There is a single tram, number 50, Krowodrag Górka. Why not? But like there is plenty of nodes. So you can take them all and make the one node from all of them and apply it for each element of the JSON we are getting. That works. We can put it on a map. It is, but we want to do this real time, so let's do it. Every 3 seconds sounds fine. So we have real-time visualization you can just have. Okay, so we know that we have a graph, but this is not something like really, really new. A lot of people have graphs, but the visual textual representation, what it is all about. The thing is that if you, sorry, I'll be patient. If you add a node on a node editor, you will have a line in the code. If you put another line in the code, the node will appear like in the real time. So each line of the code is represented by the node. You can put many nodes into one if you want to, if you don't want to have like too many of them. But still, if you need to get to them, you can just get into the node and see what is inside. What it is giving to us, like really. The clear levels of abstraction. Why it is important? If you have a client who has a complicated data flow, like really complicated, but he wants to just know the main parts of it, you are giving him like really nice graph. You can say, okay, here we are getting the data, here we are parsing it, there is the output who is giving you the certain thing. On the other hand, when the developer is coming or the guy is interested what is really, really inside, he can just get to the node where it is coming from. So another thing, if something fails, you have like clear knowledge what is failing because the node is becoming red and you get the error on the strict node, like the one. And the rest is just active if it has, if it can, like, it is just working. What are the benefits for this graph visual textual representation? Well, first of all, there is manageable complexity. You are showing to your client or the person who is using the program what you want to show. The rest can be under the hood. It improves productivity and correctness. You have the clear pipeline in the form of a graph, so you don't have to additionally draw the graph in the documentation. It is like clear. You have no communication barriers because it is like straightforward. You can see what is happening in the code. And it is really, really easy to start with. You are just downloading Studio, opening the program, pressing tab, and adding the node. This is really, really easy. So how about technical details of Luna Studio and Luna? I will tell a few things about, oh my goodness, yeah. About language design, then about type system and computational effects. So the dual representation is forcing certain design. So when we were thinking about how Luna should work, we are thinking from the beginning about the visualizations. So being the functional program is really well for this because you are applying the next functions over the nodes and you can visualize the data under the nodes. On the other hand, the nodes have to be immutable. Like the data cannot really, you don't want them to change. We are statically typed, but when you are adding the nodes, you don't want to think about the types. So you want to see them when you need them, but I can't imagine like straight flow with typing that this will be an integer and this will be real. Like this will be awful. On the other hand, people are asking, is Luna compiled or interpreted? So because of the flow, it is like obvious that there is dynamic computation going on during the work. On the other hand, if you want to cache the things or have things working faster, Luna is compiling part of it before. What about type system? Well, we really do like Haskell. Luna is written in Haskell mostly, and we really like Haskell type system. But it lacks a little bit of user ergonomics. Like, it is sometimes hard to write. We need static typing. We have algebraic data types. I will tell about them in a minute, and a polymorphism. But we also have objects. It is not object-oriented programming, but it has objects with accessors scoped to their own classes. So here is Luna code, and here is Haskell code. So as you can see, we have really simple sum type. So algebraic data types are the types we can compose from the others. We are supporting multiple value constructors. As you can see, the type foo has foo and bar inside. We have parametric polymorphism. So we have foo A, where A can be anything. And also we do support pattern matching, because pattern matching is just great and really nice to use. But what about this ergonomy I was talking about? So the accessing fields works like you would expect. In Haskell, you have to write the class, then the instances to get the certain thing from the type. So as we can see, to get just the name from in the Haskell, you have to write a lot of code. And we put row polymorphism into Luna to make working with object properties easier. How does it look like in Luna? It looks like this. So we have 3 classes, work, mobile, and random class totally. 2 of them has the field name. The third one has the method. If you want to get name, it doesn't matter if it is a field or the method. You are just creating getName method function. So let's think about 3 objects, foo, bar, and bust, which will have the name Johnny and Sam, plus the random class has such a name method, so it will work. If you want to get name from any of them, you just apply the function over the object. and it is just working, like in pure script. The thing about Luna is, in Luna, you don't have to write the type explicitly, because it has to solve it under the hood, like figure it out by itself. So what about syntax? Is there anything specific about the syntax in Luna that you may want to know? Well, we have our favorite operator, which is the dot. The dot is not like the dot in Haskell, like you don't... The dot is like in Python, so it is just the accessory dot. But it behaves differently if it has or has not spaces around it. So if you have fxy space dot space accessor, you're accessing everything what is on the left side from the dot. If it is like without spaces, it is just working on the object you have there. It is very, very simple but expressive. You don't have to use parentheses for writing the code, but you have to speak out loudly about this because otherwise there is a lot of misunderstandings. So there is the simple, I believe if you see this code, which you can read from left to the right, you can perfectly know what it's going to do. So there is laziness in Luna as well. We think that it is important because it is making the programs more efficient and faster. We don't want to evaluate everything. It is so-called call-by-need laziness, and well, there are two aspects of it. Data types do not force their fields, so if you have foo-print x type, it will not print anything, and functions do not force their arguments, so if you have a function if then else, it will print just once, not twice. But there is always a but. Each line, there is a strict twist. Each line is a monadic binding. What does it mean? If you call a function, it will be, each line of the function will be evaluated. Why is it? And what it is like more about this? So, lazy data types, if you have just print Luna, it will not print anything unless you call directly. So if you call foo.get, you will get the thing from the data type, from the maybe inside. The function arguments, if we have the function const, which is lazy about the second argument, it will never print anything. If we want to think about it more, we can tell about lazy and effectful mapping on lists. So we have a list with 3 things inside, 3 strings. I'm sorry. And we have 2 functions, 2 methods on it. So we have mapping, which will just return a list of things. And we have each, which will evaluate each print immediately. The each is like sec in Haskell, if you know. If you want to see the direct implementation, you can run into the code. Why is it even important how we do the laziness? Because we want to show the data under the node. We have to somehow force the program and be sometimes strict. But we don't want to evaluate everything, just as much as we need to visualize, to do the visualization. So, where we are. So, we have open sourced half a year ago, in January. We have FFI, so bindings to C, right now. We have wrote the whole project in Haskell. So we have Haskell in the backend, then Haskell compiled to JavaScript, and the JavaScript on the front end. Our main struggle at the beginning was the performance, the backend performance. So we have finished the work on performance, and we are about to release it. We are testing it right now, and we are about to release it in 2 weeks, I think. The improvement is like 200 times, so this is like really, really, really good. And the new graphical user interface release is coming. Like, I cannot wait to see it, because we had React to draw things at the beginning. Now we will have WebGL. So, and we are working on the libraries. Like, for the early stage language, it's really, really important. Where we are. So we are based in Kraków, but if you want to see what we are doing, GitHub is all yours. Like, all the repositories are open. You can see what is going on. The website, luna.org. I made the mistake. There should be a pause, not a dot between Luna. I'm sorry. Yes, the chat is correct, and the Discord as well. I'm sorry. So the chat is the Discord server. If you want to get in touch with us, you can just write to us. There is a lot of public channels there and a lot of people, so we are responding. And for the bigger things, we have forum. Yeah. So, and I have stickers and pins if you want.
Thank you for your talk. I wanted to ask, so you a few times you mentioned that you specifically wanted static types.
Yes.
But could you elaborate why in your specific project, like Luna, the static typing is so important?
Because it allows you not to blow your code into your face. Like, it is more, how would you say it?
Yeah, I understand the idea of why static typing is matter. I mean, like, targeting the visual representation, which is, as I understood, is practically more important and more. You focused more on that.
Yes.
It's not obvious why static typing matters for visual representation.
It matters for writing the code. The visual representation is main thing to visualize the data or the flow, but still you want your code to be as good as it is possible, and static typing is just helping you. So if you are giving the user the static typing where the user doesn't have to think about this, but the type checker and interpreter is doing his job, and then can early tell you, okay, here you should have the integer, and you just put text, so it will be a mess in a minute. It is just better.
So basically, it's better errors.
Yes.
Okay.
And better flow. Yes.
Just with the whole visual thing, if I got it correctly, this is not visual programming, right? So it's like the nodes don't correspond to the code. They're like just to inspect the data, the input output. Or
each node is like single line of code is the single node.
Okay,
so if you have the function so if you had 10 nodes and you put it all together into the one, you group it exactly, and you have the function which will have 2 inputs and 1 output. So you will have the inputs and the output and the self-port, of course.
Okay, so it's much closer to visual programming then.
Yes.
Okay.
Hi.
Hello.
I wanted to know what is your plan about packaging system?
We are working on it. Like, we have some ideas about this, but right now, well, first things first, we were working more on the performance side. So if you want, I know that there is a huge document about it but I am not the expert and I was not working on it. If you want, I will send you the link to the RFC.
Will you have themes, like colored
Yes.
color themes?
Well, actually, I maybe should say one more thing. How it is built like from scratch. So we have the server with the backend, and then we have, everyone knows what Atom is. So we have the Electron application, which has a plugin with us. So there you can work on the themes and set up it and add more things. We are planning to get rid of Atom and build our own custom Electron application using ACE or something like this for text editor. But yes, customizing with the colors and everything is important for us.
Besides running the program in the browser, what other output executable formats do you support or do you intend to support? So can you compile to a binary that I can
Not
drop on
yet.
the system?
Yes, not yet. We wish, but not yet. We are working on it. We have also the PhD working on serverless Luna, so it is going that way, but slowly.
I was wondering how the system represents graphically the various data types.
You have, well, if you think about the whole graph, there is the data type which has the type structure.
Will you be able to define your own data types and
Yes.
your own representation for them, a graphical representation?
Like changing the colors. Colors are like from like
The circles of the node.
You're making a square.
Yeah.
not yet, but maybe in the future you can do your own visualizers, so you don't have to rely on the things we are supporting, but you can do anything you want and visualize it like anyhow you want. We cannot change the colors of the types yet, but maybe.
I have a question about accessibility.
Yes.
Have you discovered that it would be easier, for example, for people who have a hard time typing to code with Luna or visual computing, or for them, for kids that
Yes.
are not familiar with keyboards or mouses?
Yes, that's why if you just, well, the nice thing is that creating the graph is so easy that you can just, okay, we have still like strong attachment to the keyboard because you have to press tab and then type something. But on the other way, I'm sorry, it is really easy because, okay, you are doing something on the node with integer 3 and you want to pass it to another node which will do something else with it. So you don't have to move, click, next, space, press tab, type the node 1 name dot something something. You're just pressing the tab and it is just appearing. So we are going that way, but getting rid of the keyboard will be really hard. So the clicking, and it will be slower, I think, for the developers.
Do you support feedback and or state in these code graphs?
Once again,
Feedback or state?
I don't understand.
For,
Loops? Like if
for instance, if you have a stream of data coming in and you want to add them together over time.
yeah, you can do this. So you have just one node, you string data, anything you want. Then the other node where you are stringing data, then you are processing them. You can cross them to the one node. This is not a problem.
But that's combining two streams, right?
Yes.
I have one stream of data coming in and I want to add it to itself over time to have like a total.
You can like duplicate the node, or
But the node should be a reducer.
yeah.
Can it be a reducer of the stream accumulator?
I have to think about this. This is a good question.
The graph, when you draw the graph out, can the graph have cycles in it?
No, I believe not. They shouldn't be. So, thank you. It was really nice. I don't know, one more. I'm sorry?
What about the size of data? So should the data fit the memory, or you do have any kind of limitation? So for the front end, for sure, but even in the back end, how it works?
Well, this is all about the new car also as well, because they have worked about this. Well, Luna is more for the streaming data than the regular big data you want to process, like 10 gigabytes of things at once. It is more efficient to do small things than to do like the huge big data right now. Is it like...
So this does mean that if you have more... If your data doesn't fit the memory, you have to split in batch and process it.
Yes, I am aware, and I don't feel that I can respond to you like perfectly. So I will ask you to call us or like come to our discuss, and we will, yes.
Okay, thank you.